Okay, Algebra 2, Unit 1, Lesson 11 is called Adding Up. I don't know why I'm booing you guys, but you should be excited. All right, so our learning goal is I can look at sequences and find the sum of the terms. So quick review on adding fractions. We need to get common denominators here in order to add fractions. So this has got to get multiplied by 2 over 2. So it's going to be 2/4 plus 1/4 equals 3/4. Remember, you add the numerators, you keep the denominator the same. Next one's going to be 4 over 8. I multiply this by 4 over 4, and this by 2 over 2. 2 over 8 plus 1 over 8. Add those all up, and I get 7 over 8. Come over here, we're going to get same thing this time. Our denominator is going to be 16, though. So this is times 8 over 8. This is times 4 over 4. 2 over 2. So I get 8 over 16 plus 4 over 16 plus 2 over 16 plus 1 over 16. Add all of those up, and I get 15 over 16. Last one, same idea. First one by 8 over 8 to get 16 for my common denominator. Next one's going to be 4 over 4. Next one, you multiply by 2 over 2. And then the last one can stay the same. Add all your numerators up. I think it's 45 over 16. A little review there on common denominators and adding fractions. All right, so let's look at this. Tyler has a piece of paper and is sharing it with Elena, Claire, and Andre. He cuts the paper to create 4 equal pieces, then hands one piece each to the others and keeps one for himself. What fraction of the original piece of paper does each person have? So I drew this out here. So we got Tyler, Elena, what are the other names? Claire and Andre. Claire and Andre. Okay. So each person has 1/4 of the original. Okay. So this one would be 1/4. Very simple. All right, let's take a look at number 2. Tyler takes his remaining paper and does it again. He cuts the paper to create 4 equal pieces, then hands one piece each to the others and keeps one for himself. What fraction of the original piece of paper does each person have now? I'm going to go over here, and basically I'm going to take Tyler's paper and I'm going to split it into 4s. Okay, and everyone's going to get a piece here now. Tyler, Elena, Andre, Claire. Now the other ones stay the same. That's still Claire's. That's still Andre's. And this one is Elena's. So what fraction does each person have here? So if you look here, this piece here is 1/16, because if I drew this here, there'd be 4 before there, and there'd be 4 there. If you count those up, there'd be 16. So I'm going to just erase those so you can see them. Okay, so really, Tyler has 1/16 of the whole paper. Now Elena has 1/4 plus 1/16. Same with Andre, 1/4 plus 1/16. And same with Claire, 1/4 plus 1/16. So I'm only going to do it once. I'm just going to add it one time. It's going to be the same number. I multiply this by 4, I get 5 over 16. Okay, so if I go back there, Tyler has 1/4 still. I'm sorry, Tyler has 1/16. Tyler is 1/16, and then the other three. 5/16, okay? So then we go down to the third one. Tyler takes his remaining piece of paper and does it again. What fraction of the original piece of paper does each person have now? What happens after more steps of the same process? Okay, so I'm going to take Tyler's here. I'm going to split it up. Okay, so we got Tyler. Oops, I'm sorry, this goes in here. Claire. Lena. And Andre. So each one of those pieces is going to be 1/48. Because basically, if this was 1/16, and I split those in four, it's like you're going to times that by 4. Actually, wait, no, it's going to be 1/64th. Because there'd be 4 here, and another 4, 4, 4. So each one of those would have 16. So it's 16 times 4, yeah, it'd be 64. Okay, so this piece here is, and I'll just stick with Elena, 1/64. So let me erase some of this here. So let's just do Elena. Well, Tyler's easy. Tyler is 1/64 because he's only got that one little block right there. Elena is going to be the same as everybody else. I'll just do hers. 1/64 plus 1/16 plus 1/4. Add all those up. (21/64). So we got Tyler 1/64. Everyone else. What did we say? It was 21/64. Okay. So the question here is, what would happen if we keep following this pattern? So, the next step we're going to add, it's going to be 1/128 for Tyler. You can kind of see it's timesing it by, no, I'm sorry, timesing it by 1/4 basically. So Tyler's would be 1/64 times 1/4. That'd be 1/256. And then everyone else, it would be, you take what they had before, and you would add, you go back to here, you basically take what they had before, which was this, and you would add the 1/256. Okay, so you can kind of follow the pattern there and keep adding it up. All right, so I had that, but I just ended up dividing myself. All right, here's the next situation. Here's a geometric shape built in steps. Step 0 is an equilateral triangle. Okay, so this is step 0. Oops. Looks like a 6. To go from step 0 to step 1, take every edge of step 0 and replace its middle third with an outward facing equilateral triangle. So this will be step 1. And then to go from step 1 to step 2, take every edge of step 1 and replace its middle with an equilateral triangle. So kind of the same thing here. So I'm going to just draw my triangles right here. Every edge. So we get something like that. So that would be step 2. Okay. Now let's go on here and see what it's asking for. Find the equation to represent function s, where s of n is the number of sides in step n. What is s of 2? So, well, let's just start here. S of 0 was 3. S of 1, S of 2. So we're going to count the sides of the triangle. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then when I go here, I count all these sides up. It's going to be, all right, start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I ended up getting 48 when I counted them up. All right. So it looks like it's a geometric. It looks like it's times 4. So if I want to do my recursive, S of n, take 4 times the term before it, and your first term, S of 0, is 3. So there's my recursive formula, right? Find the nth term, you take the previous term, times it by 4. Okay, and then we say what we start at. I wanted my explicit formula. Let's see here, I start with 3, and then it's times 4 to the n. Now I can use 4 to the n, I don't need n minus 1 because I start with the 0 term. And then if you want to check it, if you're not sure, you can just plug in, what is s of 2? Well, it'd be 3 times 4 squared, which would be 3 times 16 would be 48, so that would check out, okay? So these would be my 2 equations. All right, consider a different function, t, where t of n is the number of new triangles added when drawing step n. So let t of 0 equal 1. How many new triangles are there in steps 1, 2, and 3? I'm going to go back here. How many new triangles? So this one we started with 1. New triangles I had 1, 2, 3. So t of 0 is 1. T of 1 was 3. If I go back here, how many new triangles did I have? So I'll start here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so you can kind of see, the pattern here. If you look back here, the number of triangles is dependent on the number of open sides. So the steps are kind of off by 1. So if I look here at t of 1 is 3, whereas s of 0 was 3. And then if I look here at t of 2 is 12, s of 1 is 12. So now I can kind of logically figure out that t of 3 is going to be going with s of 2, so that would be 48. And that makes sense because the number of triangles depends on how many sides you have open. All right. Go down to number 3. What is the total number of triangles used in building step 3? So what would be the total number of triangles used in building step 3? So in order to figure that out, we would basically have to add them all up. Okay, so if I take all of these here, 1, 3, 12, 48, if I add them up, that should give me the total number of triangles that we had to use. So that would be 64. Okay, so we're adding up all of those to get that answer. All right, lesson synthesis. What would it mean to find the sum of the sequence defined by f of 0 equals 3/10? And then they give us a recursive formula, f of n equals 1/10 times f of n minus 1. So we're basically just multiplying by 1/10. So let's draw it out. So if I times this by 1/10, I get 3 over 100. Times that by 1/10, we get 3 over 1,000. And you can kind of see the pattern here. And what happens is these numbers start getting so small that it's almost like you're adding nothing on. But it says find the sum. So instead of putting commas here, we'll just put plus signs here. Let's change these to plus signs. I'm going to add them up. And what's going to end up happening is eventually you're adding such a tiny little value on that it's almost like you're adding nothing. It'll level off, basically. So let's see if I keep adding them up. And keep adding them up. Let me add them in my calculator here and see what we get. So what ends up happening is it gets really, really close to 1/3. Okay, it ends up being like 0.3 something. Okay, really close to 1/3 if I add them up. Okay, so 3/10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10,000 plus 3 over 100,000. And I get 0.33, yeah, I get 0.33333. So pretty close to 1/3. So it's going to end up like leveling off there because it's almost like you're adding such a tiny value, it doesn't really affect it. All right, cool down. Lynn spent 80 minutes doing homework on Monday. Each day from Tuesday through Friday, Lynn spent half as much time doing homework as the day before. How much total time did Lynn spend doing homework from Monday through Friday? Explain how you know. So Monday, Lynn spent 80 minutes. Each day from Tuesday through Friday, Lynn spent half as much. So Tuesday would be 40, Wednesday would be 20, Thursday would be 10, Friday would be 5 minutes. But we want to know the total, so we're going to have to add them all up. So what does that give me? That's 155 total minutes. All right, so basically we're taking what we know about a sequence and a series or sequence, and we're just based on the situation, we might have to add them all up and find the sum. So that's lesson 1.11 for Algebra 2.